Hi, today we're looking at section 2-1, using inductive reasoning to make conjectures. Take something out to write with and take notes on, complete the check it out problems at the end of each of the examples, and write down any questions you have.
Alright, so we're going to look at our learning targets. They are, and they're already checked off for you, use inductive reasoning to identify patterns and make conjectures, and then B, find counterexamples to disprove conjectures.
Interesting. So here we have the next three items in the pattern. Again, here we start with January, March, May. Notice we're skipping every other month. So our next one is going to be July. And the key word here is a pattern we're looking for.
Wow, all the answers are there. Isn't that great? Here's the next example. Find the next item in the pattern. So if I look, I add 7 each time. And so the next one would be 28 plus 7, or 35.
Nice job. And here, looking at our triangles, we start with the triangle going up, and then it looks like it rotated to the left, then clockwise or down, and so it's going to be going to the right now. Again, we're looking for patterns, inductive reasoning.
All right, so find the next item in the pattern. This is one for you to do. So look at these and see if you can figure out what the next one would be.
Okay, so there are several examples where you form a pattern, assume the pattern will continue, and that's all using inductive reasoning. So we're looking for a pattern, we're assuming it's going to keep happening. So inductive reasoning is a process of reasoning that a rule or a statement is true because the specific cases are true. You've observed something, you think it's going to continue on. Based on that, you have your conjecture, which is a statement you believe to be true based on inductive reasoning. So based on what you've observed, that's what's going to happen.
All right, so here is an example. The sum of two positive numbers is blank, and you already saw the answer, but we're going to go through the process. I don't necessarily know what the answer is, so I'm going to just start coming up with examples. Two positive numbers. 2 plus 1 is 3. 2 plus 2 is 4. 3 plus 5 is 8. So I don't see a lot of things in common with these, but I do notice that they're all positive. So that is one true statement I can make about them.
So that was your conjecture. Nice.
That's my conjecture. Sometimes you can have multiple conjectures about the same problem.
So here's another one. The number of lines formed by 4 points, no 3 of which are collinear, is blank. So again, off the top of my head, I don't know, but I can start with making my 4 points and then drawing lines and see how many lines I can connect in there. And then we can count them up and be good to go. So I can get 1 line, 2 lines, 3 lines, 4 lines. It takes 2 points to make a line, so I can also do diagonals here and there, which will give me a total of 6 lines. I like colors. So, as Miss Briscoe did and I did here, make some examples so you can have an idea of what's happening.
All right, this is one for you to try. Complete the conjecture, fill in the blank. The product of 2 odd numbers is blank. So find some examples of multiplying 2 odd numbers and see what you notice about them.
And here's an example. The cloud of water leaving a whale's blowhole when it exhales is called its blow. A biologist observed blue whale blows of 25 feet, 29 feet, 27 feet, and 24 feet. Another biologist recorded humpback whale blows of 8 feet, 7 feet, and 9 feet. Make a conjecture based on the data. Resume. So based on the data here, we observed that blue whale blows at 25 feet, 29 feet, and 27, 24, where the little humpbacks are at 8 feet, 7 feet, 8, 9 feet. So our conjecture is going to be that blue whales blow higher than humpback whales. And that's our conjecture. That's based on observations. That's what we come up with. May be true, may not be true, but we just observed.
You may come up with something else. Who knows? All right, this is yours. Make a conjecture about the lengths of male and female whales based on the data. So look at the table and see if you can make some kind of conjecture.
Based on observations. Now, to show that a conjecture is always true, you must prove it true. The nice thing is to show that conjecture is false, we only have to find one example where the conjecture is not true. And that example is called a counterexample. And a counterexample can be a drawing, a statement, or a number. And for sometimes a drawing might be the best way to state it, other times a statement, or sometimes just x equals 2, a particular number is going to tell you.
Just remember, a counterexample has to be specific. It can't be too general, so just be careful. So here's what we know about inductive reasoning. We're going to be looking for a pattern, if we can still see it. Looking for a pattern. Then, based on that pattern, you're going to make a conjecture. And then you want to check the conjecture to make sure it's true, else find a counterexample to show that it's false.
So in this one, we want to show that the conjecture is false by finding a counterexample. So we know that it's going to be false. We're told that. So for every integer n cubed is positive. So we're thinking, so integer, those are our positive and negative numbers, including 0. So when n is 1, n cubed, 1 cubed is 1. Well, that's positive, so that's not working so well. Now let's pick a negative number, and n is negative 1. Negative 1, make sure you cube negative 1's your base, and that's going to be negative 1. So right there I have a counterexample. When n equals negative 1. It's my counter. So when you're doing these, sometimes you want to check your integers, in this case it has to be an integer. When it says real numbers, you have your decimals and other numbers that you can check, and other sets of numbers.
All right. Show that the conjecture is false by finding a counterexample. Two complementary angles are not congruent. So we want to find a counterexample, an example that shows that two complementary angles can be congruent. Remember, complementary means they add to 90 degrees. So what case would allow you to show that whoops, that's not a very good angle, that two angles are congruent but complementary, which would be the counterexample to that. What would be when angle 1 is equal to 45 degrees and angle 2 is equal to 45 degrees? So there we have two angles that are complementary but are congruent. So we have our counterexample.
And in this case, this is really the only counterexample that would exist.
Right, so it is the only counterexample. So sometimes there's an infinite number, like the one Miss Aiken did, where any negative number would be a good counterexample. This one, there's only one.
And let's just go past this puppy. We got a lot of those. Here is yours now. Check it out. Show that the conjecture is false and find a counterexample for any real number. It's a much larger set of numbers now. Real number x squared is greater than or equal to x. Good luck.
And here's another one. Find a counterexample for the statement, supplementary angles are adjacent. We're done. Here's our summary. Hold on. Here's a quick review of the whole thing, and then we get to the summary. So our summary, 3 steps of inductive reasoning: look for a pattern, make a conjecture, prove the conjecture, or find a counterexample. And we are going to learn how to prove a conjecture later in this chapter. It will be lots of fun.
What an exciting time.